Hi everybody. Okay, we've been dealing with transformations and we did translations, which is the sliding. We've done some dilations, or we compressed and we stretched, and we've actually done reflections also over the x-axis. So what I'd like for you to do right now is I want you to pause the video, and I want you to try these three problems on the first page. These are kind of like problems we've done already, but they're only dealing with one type of transformation at a time. And then what I want to do is look at a strategy for doing with multiple transformations. So pause it, give this a shot. I'm going to go ahead and hold off for a second and then I'll have you come back to your work. All right, so I'm going to go ahead and graph. I'm hoping that you have done this and given this a shot already. Describe the transformation of f of x equals x squared that this function is, f of x equals x minus 3 squared plus 2, and then give the domain and range of, let's do it of the transformed function. So the regular function, we've done this a lot. I'm going to try to go without the table. You know, the 1, 1, and then the 2 squared is 4. 3 squared is 9, 4, 5, 6, 7, 8, 9. And then I got the negative 1, 1. I go 2 over here and 3 over here. So this isn't the one where you're asked to graph. This is the parent function. But I'm going to take this function and translate it. And I'm going to translate it 3 units right. Remember, it's a minus, so we're going to go right, and 2 units up, 3 units right. So let's take this vertex, move it 1, 2, 3 units, and I'm going to change the color because I've got this fancy pen. 3 units right, 1, 2, 3 right, and 2 units up, and I'm right there. I could take this point, move it 1, 2, 3, up 1, 2. I'll bet when I do this, I'm up over 1, 3, and up 1, 2. I'm right there. If I could take this point, I go 1, 2, 3, up 1, 2. I could take this point, go 1, 2, 3, go up 1, 2, and so on. And I might run out of room if I try any more. But this is my transformed function. Its domain is not going to change. Negative infinity to infinity. And its range looks like it's got a starting place at 2. It's a low point of 2, and the high point is not bounded there. Okay? Now, I'm going to use red for the parent functions on all these. I'm going to graph the parent function, and I'm going to transform this to this. The parent function, I don't know if you remember that V, it kind of cuts these squares right along here, right in half from the origin. And goes like negative 1, 1. This is absolute value. Okay, so there's the parent function. And the transformed value is 1/4. So we are going to compress by a factor of 1/4. Now, we could do this within the tables, and that may not be a bad idea. Let's try it two ways. Let's just try it with the graph, though, also. You know, I'm at 1 here, and let me go blue for the transformed. If I multiply 1 by a fourth, I'm down here at about a fourth of the way up. And here I'm at 2. And if I multiply 2 by 1/4, 2 times 1/4 is a half. Here I'm at 3. 3 times 1/4 is 3/4. Here I'm at 4. 4 times 1/4 is 1. I know 4 times 1/4 is 1. I'm going to go out to 8 because that's an easy one to do. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, a fourth of 8 is 2. So, my transform function is this blue one. And then I kind of do the same thing here. I'm going to go over 4, 1, and then 5, 6, 7, 8, go up 2 to follow that pattern there. I'm just trying to do it kind of quickly. But I'm wondering if you got the same. We compress it. We really smashed that thing down and it widened out. Okay. Now we're going to describe the transformation by this -2. Ooh, dear. Okay, I got two different types of functions. I just forgot to change that. So let me think. Well, I think we still want to deal with this one. So let's change this rather than that one. Let's change this to the absolute value of x. All right. So we've already kind of, I am going to graph the parent function again. Very carefully. Cutting each one of these squares in half on the grid. So I'm going to take each value, like the y value here, I'm going to multiply it by -2. So 1 times -2 is 1 times -2 is -2. 0 times -2 is, and here's 2. 2 times -2 is -4. -2, -3, -4. Here is 3. Would you agree that that y value is 3? 3 times -2 is -6. -2, -4, -5, -6. Here's 4. Y is 4 here. 1, 2, 3, 4. The coordinates this are 4, 4. If I take my y coordinate, multiply it by -2, I'm going to be down here at 4, -8. So here's 4, here's -4, -5, -6, -7, -8. I'm about out of room here. Whoops, I think I miscounted. This is -6, -7, -8. I sure did. Okay, forget that point there. So, oops, I said I was going to draw the transformed one in blue. And if I kind of come over here, it is reflecting there, so I'm going to get these points real quick. 3, here, there's 4 to there and 4 to there. So there's the other half of the V there. So there's my transformed. This is the transform. This is the graph of that. Domain. Okay, domain is interesting. No, domain is not interesting. Domain's always what it is. -infinity to infinity. The range, though, is more interesting. We go to the low point. Well, the low point never ends. It never finds that low point. So that's -infinity. We get to the high point. Don't count the red, just count the blue. The high point, it gets up to 0, but that is it. All right, so there's the first page. with just the single transformation. This actually is kind of two transformations because you're reflecting and you're stretching it. All right, second page. I've got multiple transformations here in this graph, and then we're going to give the domain and range after we graph it. With multiple transformations, we will graph the parent function. The parent function is f of x equals x squared here because of the x squared. We will flip it if we need to flip it. We're going to flip the parent function. So I'm going to make a few graphs here. We'll compress or stretch it if we have to. That's what the or not means. If it's just one, we don't have to do that. And then we will slide it if we have to. So parent function, and we flip it, we stretch or compress it, and then we slide it. All right, so let's graph f of x equals x squared. Parent function is going to be in red. So we do that. Remember the 1, 1, 2 squared is 4, 3 squared is 5, 6, 7, 8, 3 squared is 9. We get here, here, 3, here. Okay, so here is the parent function. Okay, do we need to flip it? The answer is yes. We have to flip it because it's negative. So let's flip it. So now I'm going down one instead, and now I go 4. 1, 2, 3, 4. Flip it means reflecting. And then we have the 9, I think. 5, 6, 7, 8, 9. Okay, so I flipped it. Check. Compress it or stretch it. We're going to compress it by a half. What color there? I'm going to go black on that one then. If I compress this by a half, half of -1 is -half. Half of -4 is -2. Half of -9 is 4.5. Here's 3, 4.5. And then we come and do the same things over here. Okay, and I'm just kind of looking over at the reflection there. So now I have that drawn. Okay. And then we take it and we slide this point. Okay. We do slide it. 3 units left and 4 units down. 3 units left and 4 units down. So I'm going to go 1, 2, 3. Oh, what color are we doing here? Let's do purple. 1, 2, 3. I'm doing just this vertex point right here. 1, 2, 3. 1, 2, 3, 4. It's getting messy here. And let me move this one. I'm just going to move this one and this one. I am going to move this one and this one. And what did we say? 3 left. 1, 2, 3. 1, 2, 3, 4. And this one, I'll move this one here. 1, 2, 3, 1, 2, 3, 4, right there. Okay, now I'm just going to draw from these 3 points the curve. All right, here is my final answer right here with the multiple transformations. Okay, let's just kind of back up. I don't want anybody getting too upset about this if they're having trouble with it. But we will graph the parent function. I flipped it. That's the blue part right here. I didn't change the sign. I did compress it. Each y value here I multiplied by a half and put it here. So this 2 I multiplied, or wait, this 4 I mean, I multiplied by a half and got 2. And this 9 I multiplied and got 4.5. And then that was the compression. So that's in black here. And then the slide of that came from the 3 units left and 4 units down. This order, so I've actually made 1, 2, 3, 4 graphs, and the 4th graph is the actual transformation of that. Okay, so this is about as advanced as it gets. Now, the last one we want to do here together is we're going to give the equation of this function that's graphed below and its domain and its range. All right. Oh, I suppose get the domain and range here. Let's do that. The domain is negative infinity to positive infinity. The range is negative infinity. When it's facing down, it doesn't have any bottom to it, but it comes up to the high point here of -4. That is the highest that graph is going to go. That function, that's the highest function of y you're going to get. Highest value of y you're going to get, I should say. Okay. Now, I'm just looking at this one. The parent function is f of x equals the absolute value of x. I'm going to leave a little gap here because it looks like we've split it some. And we can deal with that part first. I went 1, 2 left. 1, 2, 3 down. 2 left and 3 down. So 2 left, wouldn't we go plus 3 there and 3 plus 2 there, and I mean 2 left. And then minus 3 there. Okay, now I think the key here is figuring out what that number here is. If you recall, I would go I go up 1 unit here. The graph actually from here goes up 1, 2, 3 units. So it's 1 unit here, it's 3 units here. I think that is our multiplier. And if you look at how it goes up from here, from the bottom here, it goes up 1, 2. The actual graph will go up 2, 3, 4, 5, 6. It looks like so there's 2, here's 6. 2 times 3 is 6. That's tricky. I think just give it some practice here, and I'm going to have you just work on the rest of this packet. And you can bring that in, or just upload it on PowerSchool. Be due Thursday. Okay, you guys have a great day. Thank you.